Hey, and welcome back to another episode of Pizza Legends. In this video, we're going to refactor a lot of our previous hard-coded canvas drawings with reusable components called GameObjects. GameObjects are going to be a core building block of our game as we continue to build it. Anything you see on the map, like a person or an item you pick up off the ground, basically anything you can interact with or move around, push around, those are all GameObjects. Let's go ahead and get started. So quick recap, here's where we left things in the previous video. We have an overworld component, and in its init method, it's creating an image to use for our scene background, and then also doing quite a bit of work here to create a hero on the screen and then a shadow underneath the hero's feet. And so here's what it looks like again. So here's our one hero on the screen, and he looks good and stuff, but in this video, what we want to do is start thinking about how we can consolidate a lot of this code to sort of componentize the concept of a person on the screen or an NPC on the screen. And furthermore, we're not just talking about people on the screen. We're going to have like items you can pick up and boxes and cash registers, pizza stones. This game's about pizzas. And so what we want to do is sort of abstract all that into a concept called a game object. In any given map, we're going to have a variety of different game objects, and each one will be configured with its own behavior. And so let's go ahead and create a JavaScript file for that type of component. So I'm going to make a new file called GameObject.js. I'll go ahead and fire up the class here. So we'll call it GameObject to match the file name. And in it, it's going to have a constructor, just like our overworld did. The constructor will take a object of different values we can pass in. I like the object here because then we can kind of continue to add and play around with the things that get passed into the constructor without having to worry about, the order of values or that kind of thing, and how many values are passed in. It's just a little bit easier to refactor this way. You can think of it as like props in something like React maybe. Here we're going to start carving out some state that will be contained within this game object. So we already know from before that any game object is going to have a position, so we can capture that with like this.x is 0 and this.y is 0. What we want to do is really be able to like pass in the value for x and y. Like this character should start over here, this character should start over here. And so what we'll do is say config.x, and then if we don't pass one, we can just default to 0, or if it's a falsy value like 0, it'll just end up being 0. And we'll do the same thing for y. We also know that each game object is going to have its own appearance. So like the hero we have on screen right now, we're passing in a hero skin to use for that. If we have a different person, like a different NPC, or just like a box, they're going to have a different art asset they're using. And so what we're going to do is create a concept of a sprite. And the sprite's going to kind of capture the appearance of what this game object should look like. We're going to go into a fair bit more detail here on the sprite. And so what we're going to do just for a second is set it to null. Now the sprite itself is going to have a fair amount of detail and state within just itself. Let's go ahead and pull open a sprite again. And here's like our hero image. You can see there's a lot of different details in here where right now we're only showing this one frame. But in theory, we want to show like an animation frame or an animation series of the hero walking, right? So like starting this frame, then show this frame, then this frame, then this frame. Or if the character is currently turning in a different direction, like say to the right or the left or facing up, then we want to show this frame. And so that in itself just has a bunch of state on like what am I showing now? What should I show next? When should I show it next? And so all of that, because there's so much detail there, we're going to go ahead and capture Sprite as its own class too. So back to the code, what we're going to do is actually create a new file. We're starting to grow here. So it's going to be called sprite.js. And just like before, I'm going to create a new class with a constructor. And so with this constructor, we can start passing details in to sort of configure how the sprite should look and the different animations it can play. In here, I'm going to start describing the possible animations with code. So we're going to call it this.animations, and it's going to be whatever we pass in, of course, but we're going to go ahead and give it a default. And the structure of this thing is going to be an object that has keys on it. The keys are going to be the name of the animation, and then each animation will have a series of frames. The first animation we're going to add here is the one that we've already been using, the one where it looks like this. The hero is just kind of standing. It's that top left frame in the sprite sheet. And we're going to call it idle down. And that's going to be an array of frames, and each frame is a pair. We're going to have an array of arrays. It's going to look just like this, idle down. And what this is saying is that this series is just going to play this frame. Say in the future, we're going to have something that looks like this. maybe it's walk down, and then that's gonna have multiple frames in it, say like 4 of them, and the frames will look like 1, 2, and then 3. And so this is gonna be X on the left, Y on the right. We're gonna play this frame, then this frame, then this frame, then this frame. And so again, in the sprite editor, that looks like this frame, then this frame, then this frame, then this frame. We're not really gonna be using this yet, so I'm gonna go ahead and take it out. And then also remember, we've set this up so that any game object can kind of pass in its own definition of animations. So this way we have maximum flexibility for different types of objects, kind of defining their animation behavior in different ways. Next, we're going to add some values that help us capture the actual animation and the frame within that animation that should be showing right now. So right under this .animations, I'm going to say this .current animation is going to be the name, or it's going to be equal to a key in our animation set here. And so we're just going to default this one to idle down. You could also pass this in though. So let's go ahead and say config.current animation. So that way, if we want to start in a different animation than the first one, we can pass it in. Next, we want to know which animation frame should be showing. And so that's going to be which array within the array are we displaying. And we can just capture that with, how about current animation frame? And we'll just start with 0. Now the sprite component here is really the thing that should manage everything visual about what we're showing on the screen. And that includes that bit that we did before around creating an image and then copying the image's pixels into the canvas tag. And so if we just kind of look back at overworld, remember we had all of this kind of business going on. We're going to go ahead and start moving that over to our sprite object. So I'm going to be adding more code at the top of the constructor here, but first let's just leave some comments on what we're doing. So this is all configuring animation and initial state. Next, we're going to start creating the actual images so that we can kind of load their data into the canvas. And so we'll set up the image. This is going to be all the code that we did before as far as creating a new image in memory and then setting the image's source so that the right thing is downloaded. So we'll say source is going to be equal to config.source. And so that means that when we create a new sprite, we're going to be responsible for passing in a configuration. I mean, basically the same thing that we did here. It'll just be a little more dynamic. And then let's set up our onload handler. So image.onload is going to be another arrow function. And when it loads, we're instead of just drawing it directly to the screen here, we're going to just go ahead and kind of add a flag that tells us that the sprite is loaded. This way we won't try to draw before we know this flag is set to true. Now to actually draw the sprite to the screen, we can go ahead and set up a method for that. So down here, I'll give us some space. I'm going to set up a new method called draw, and this is just going to take in the context that we want to draw to, so that if we have multiple contexts, we can kind of pass in a different one if we want. First, we're going to move over all the code that we had over here, but there's just kind of a few kind of cleanliness things we want to do first. So first, let's set up a clear X and Y that has that nudge stuff kind of built in. We want to be using the X value of the game object that is associated to this sprite. And we haven't actually set that up yet, but we will in a second. So what we're going to do is say this game object sprite, game object, if I could type, .x, and then put the grid in there, times 16, and then go ahead and apply that same nudge that we covered last time. Because the sprites are cut a certain way, we need to sort of nudge them back into place. And then let's go ahead and do the same thing with Y. So Y, game object, and then the Y nudge is minus 18 pixels. Now with this in place, we can go ahead and bring over some of our drawing code. And so we'll just say the context that was passed in, we want to draw an image to it. First we want to pass in our image as that first argument, and then we're going to start passing in the 9, or I guess 8 other different arguments that need to go in here. So just like we did before, it's going to be the left cut and the right cut, and then the size of the cut. So again, that's 3232. Now we're going to use our XY. That's the position that the sprite should be drawn to the canvas. Remember, we did all this last time. And then finally, the size at which it should be drawn, which again is just 32 by 32 for us. It's worth noting here that in your game or your project that you're working on, if you wanted to use this concept and you were working with sprite sheets that weren't always cut the same, you can maybe pass in that configuration here. Like if you had a sprite sheet that was designed in maybe 8 by 8 squares, or even like, I don't know, 10 by 2 rectangles or whatever, you could go ahead and pass in that here. This project though, we're always gonna use the same size cuts in our sprite sheets, so we're just gonna leave it like this. Now GameObject here has not been added to the sprite class yet, so let's go ahead and do it now. I'll do it at the bottom of the constructor here, and we'll say reference the GameObject, the thing that created this sprite. And so we'll say this.GameObject is gonna be config.GameObject. So whenever we run new sprite, we're responsible for passing in a GameObject to the configuration here. Now that was a lot of coding and not much showing, so let's go ahead and start firing this up. We're not actually including GameObject.js and Sprite.js in the page yet, so let's go ahead and do that now. Going back to my index.html file, I'm gonna go ahead and add a few new lines here. One for GameObject and one for Sprite.js. It's worth noting that these are all load blocking scripts, and then we're not really kicking the game off until init.js here. So we are good to just like load in the scripts in sort of whatever order we want. If we were doing any code outside of constructors or anything like that, then we'd have to be way more careful about the source order here. But just know that as long as init is last, you should be okay. One quick thing to do before we fire this up, we have established our GameObject and our sprite, but we haven't actually done the thing where GameObject creates a sprite yet and passes itself in as the GameObject creator here. So let's go ahead and do that now. GameObject.js, we left this on line 5 as null, but what we can do now is say it's going to be a new sprite, and then we'll pass in our configuration, knowing that we need to do a GameObject. Oops. GameObject needs to be this. This way the GameObject will have access to properties like X and Y, for example, that we use in the draw method. And next we'll provide a source, and this is the sprite sheet that should be used. This would also be the place where we pass in the different definitions of these animations. Like right now we're just defaulting to this right here, config.animations. Soon we'll learn about extending off of GameObject to make sort of specific instances that pass in their own behaviors and style sheets. We'll get to that in another video or two. But for now, I think we're good to just default to assuming this is like a person. And so we're going to say the source is going to be config.source, whatever is passed into the GameObject. And then we can go ahead and just kind of provide a default so that in the event that we're being lazy and we don't provide a source, maybe we're just prototyping quickly or we don't have the sprite sheet ready or whatever, we're just going to default to that hero image. So that if GameObject is not provided a source through the configuration, we're just going to default to this string that we've been using, which is our hero sprite sheet. All right, it's finally time to wire this stuff up and use it in our overworld. So I'll pop back to overworld.js, and I think I can just remove all of this code. It's gonna feel really good. I love deleting code. Okay, so I'm gonna just delete everything after our image section. And now let's leave a comment that we're gonna start to place some game objects. Capitalize it just to be all official and stuff. So here I will make our hero again. That's gonna be hero, but this time we're gonna say the hero is a new game object. And here, GameObject is ready to accept an X and a Y, so we can place our hero wherever we want him to go. Say X, Y is 5 and 6. And then we don't have to pass a source because we're sort of defaulting to the hero sprite sheet, remember? But instead of just one character now, let's say we had a second character. So hero, give us more room. NPC1 will be the name of this person. And we can nudge their position now just by changing these attributes. So we'll say like 7, 9, and then let's give this person a different source. In the provided directory there, which again is available in the description, there's a few different sprite sheets to use. Right next to hero, there's going to be one called NPC1. And so this particular game object will use this sprite sheet instead. It's cut in the exact same way as the hero, so the frames are already ready to go. It's just going to look like a different character. We have our game objects created here, and that's all good, but we're not actually using them yet. They're not going to appear on the screen yet. And so let's go ahead and do that. So we'll take our hero and grab the sprite within the hero's game object, and we're going to draw it to the screen, passing in the same context that we were using before. So it's going to be this.ctx. Let's go ahead and do the same thing for our NPC. And I'll show you right away, this actually isn't going to work right. There's a little bit of a gotcha here. Let's pop over to the browser and see. So in the browser here, I'm reloading the tab, but the images aren't showing up. Why is that? There's no errors or anything, but they're not showing up. And that's because if we pop back open to Overworld, we are creating the game object and then immediately calling this synchronous bit of code, which is sprite.draw. But if we look over in Sprite, this onload thing needs to happen before we're ready to draw. And even though we're technically loading a file from our local machine, it's fairly instant. It's not exactly synchronous. This little bit of process takes a little bit of time. And so we need to just kind of wait for a second before we try to fire this draw command. It is kind of silently failing right now. And the reason we added this flag here is that so we could basically just say down here, when you try to draw, make sure we're loaded first. So if I say this dot is loaded, if this is false, then the code will just stop right here. But if it's true, then we'll go ahead and start to draw the image. And let's give ourselves that bit of time that we need. And so this bit of code here is going to move very soon. What we're going to do soon is set up a concept called a game loop, where basically these drawing lines are constantly going to be firing, or they're going to fire once every frame. That way, as values like X and Y change and facing directions and all that, we're constantly going to be redrawing the most up-to-date state to the screen. Right now we're just drawing once, and that's on Overworld and Knit. And so we'll get to that soon, but just for now, to see the sprites working, we're going to band-aid it sort of and just kind of wrap this in a set timeout. Well, we'll just give it like 200 milliseconds, move these lines of code up. And now when I hit the browser and reload, you see that our sprites do load. There's two different instances and they load in the correct positions as we expected. So very exciting. We have our two game objects being utilized. That kind of allows us to quickly add new characters and stuff. That's great. But we're still missing our shadows. So let's go ahead and add the concept of shadows into Overworld sprites. Back in sprite.js, I'm going to go ahead and set up another image download kind of pattern here for our shadow. And it's not going to be the most glorious code, but it's going to get us fine. So we'll say the same kind of thing. Shadow is going to be a new image. This.shadow.source is going to be a hard-coded shadow. Just, game objects do they all kind of share the same shadow right now. This.shadow.onload, we're going to set up the same pattern as we had before. And then finally, we're going to add one little extra bit. Just in the event, we're going to have maybe some different types of game objects that have a shadow baked into their asset, or they maybe need a different shape of a shadow or that kind of thing, or they just don't want a shadow. And so we're going to add a flag that's this.useShadow. And we're going to just kind of hard code it to true right now. In the future, it's going to look like config.useShadow, or if we don't pass it in, just false. In fact, we can even just make a tiny optimization here by moving this up and saying that if we don't want to use the shadow, we can basically just only set this source if use shadow is true. So that way, if we don't want to use the shadow, then we'll never download it. Okay, and now moving down to actually draw the shadow. Remember, we want to reference back to our kind of paper analogy we had before, that we want to start from the ground up. So we're going to do shadow first and then hero on top. That means that the shadow drawing line needs to happen before the hero is drawn, or the NPC skin, game object skin. And so we'll say this.is shadow loaded, and then we can go ahead and take our context, draw another image to it. This one is going to be our shadow, this.shadow. And then because the shadow image is only cut as a 32 by 32 square instead of a whole sprite sheet, we can just go ahead and pass in X and Y. There's no need to kind of further crop into that sprite sheet like the NPC skin does. Okay, pop it over to the browser to see it. When I reload the page, now we see that we get a sprite and our shadow at the same time. I should have touched on this in the previous video, and I didn't, and I'm sorry, but I can now. You may be wondering, why do we have a separate shadow versus just baking that shadow art kind of into the sprite sheet? And it's because now we have two different layers that we can play with. And so say that we wanted to make the character appear like they're jumping or something like that, or levitating. We could go back in, and the shadow could be drawn at the floor level still, just like it is now. But the hero skin itself, we could maybe elevate. So we'll take the Y value and go like -16 or something like that. Now when I reload the page, you see the characters are kind of levitating, and having them be 2 different layers gives us that flexibility. So that's why I like to do that with shadows. I'll go ahead and pop back to the code and undo that, as much as I like levitating pizza chefs. And now we're back to normal. Okay, popping back to Overworld.js, we're going to wrap up the video now. We've made really good progress in refactoring our objects to be just kind of known components that hold their own state. There's still a lot to go though, right? So right now we are currently only showing 1 map, and then we're always showing the same 2 characters. In the next video, we're going to start associating characters to units called maps. And so maybe we're inside this demo room now. What if we walk to the doorway and now we're in a different map? We want to show a different image and a different different set of characters, different set of game objects on the screen. And so we're going to start fleshing that out a little bit more. And then I also hinted at it too, but at some point we need to start kind of updating the state of these game objects on the fly. So instead of just initializing and drawing once, that's not very fun or interactive, we're going to start getting that game loop set up so that state is always updating and appearances on the screen are always changing. From there, we can start adding in things like controlling heroes and talking to NPCs, cutscenes, all of that great stuff. And so that's coming up in the next few videos. Thank you so much for watching this video to the end. If you're getting value out of this, I really appreciate it when you hit the like button, and be sure to subscribe if you want to see more of these videos whenever they're ready. And if you're following along here and have any questions or problems, or you're already working on a game of your own and you want to tell people about it, you should totally join our Discord. We have a bunch of people in there building games. If you're building something cool and want to tell people about it, we'd love to see you there. That's all for this one. Catch you in the next episode.